Hi, this is Mrs. Schmidt, and this is the Makeup Lab for the first lab of Unit 4. It's in the cards. This is a self-running presentation. You can push the pause button on the screen anytime you want to stop and look at the slide more closely. If you have not already talked to Mr. Fain or to me, you need to pick up a procedure sheet and a set of 32 element cards. You will need to get a data sheet, and you will need to have your lab notebook. The exit ticket for this activity is the data sheet and the post-lab questions number 1 and number 2. Read the experiment overview and then proceed to the next slide. The diagram on the left side of this slide shows you the order in which the facts are placed on the element cards. You should take them out of the packet if you have not already and spread them out on the table. Each card has up to 9 facts on it about the element. The legend shows where this information is located. For example, the top number on the left side of the card is the ionization energy, and beneath that is the atomic mass, and so on. Do you recognize any of these words? If so, which ones? What do you remember about them? In class, the 3 that most of the students did not know much about or even recognize are shown on the screen. Read the first definition and look at the picture. In your science journal, in your own words, write a definition of the word. So that means that you will read ionization energy, the energy required to remove an electron from an atom. And look at the picture. Now, in your journal, think about that definition and write it in your own words. Then repeat that for the next 2 words shown on the slide, electronegativity and atomic radius. When you're done, move on to the next slide. You now have enough background information to do It's in the Cards. Take a moment to look over the Do, Put, Finish, Done slide. You will be reading through the procedure and working through the slides in the rest of this presentation in order to complete the project alone. Your final periodic table arrangement on the data sheet needs to be in ink. And based on what happened in class, it could take up to 30 minutes to complete this. When you're finished with it, you will turn it in to Mr. Fain or Mrs. Schmidt. Your goal is to put together a periodic table of your own using these 32 cards. So looking at the procedure sheet, please read step 2 again. Then, we are going to do some of these together. Look at the 3 cards shown on the screen. Choose one of the properties to examine. For example, in the first bullet point, I have asked, how does ionization energy change as you look down the cards? Remember, ionization energy is the upper left top number. So I look at the cards and I see that the top card has an ionization energy of 520, and then it goes down to 496, and then it goes down to 419. The trend I see in ionization energy as I go down the 3 cards is that the number gets smaller. Now you look at what happens to atomic mass as you go down. If you remember on the procedure sheet and the index card, atomic mass is the second number in the left-hand column. For example, I said the wrong thing. No, I didn't. It's atomic mass, 6.9 on the top card. Now you look at atomic mass, and what trend do you see? Is there a pattern in the formulas? The formulas are the letter combinations shown. The letter X represents one atom of the element. The other symbols, Cl, represent chlorine, O represents oxygen, and H represents hydrogen. Do you see a pattern in any of these formulas? What pattern? If you have not gotten the slides out of your deck already at the earlier slide, you must get them out now, because while you're looking at the slideshow, you're going to be rearranging these cards yourself at your own desk or table where you're working. Also, did you write the answers to these questions in your journal? When you have done all those steps and you're ready to move on, flip to the next slide. I've added a card to our arrangement. It's the second one on the top. Now look across these two cards. What happens to ionization energy? Does it get bigger or smaller? Now look at atomic mass. Does it get bigger or smaller? And as an aside, excuse the typo, that 0 was supposed to be a closing parentheses. Now find that fourth card that has ionization energy of 801 and atomic mass of 10.8 in your set of cards and place it into your arrangement in your workspace. Then move on to the next slide. Now I am giving you another card. Where would you place this card into the pattern of the cards at the left? And why would you put it there? Give yourself time. Look at the pattern that already exists in the 4 cards at the left, and then look at the facts on the card with the pen pointed towards it. Place it into the puzzle. Think about why you placed it there, and then move on to the next slide. The new card best fits in the top row and between the 2 cards that were already in the table. Do you know why? Take a moment to think about it if your answer didn't match. It really is okay if you put your card elsewhere so long as you had a reason for it, a reason for placing it there. Think about what you might have done and what this solution shows. Why does this card fit best in the location shown in the diagram? Look at the pattern of ionization energy, atomic mass, and the formula for the hydride. That's the formula that has an X and an H in it. When you have done that, move on to the next slide. Two new cards are shown on the table. Find these in your deck. Place these next 2 cards into the table where they best fit into the pattern of the cards that are already on the table. So look at the 2 new cards and fit them into the table with the 5 cards that already exist. Remember, you're looking for patterns in the number trends and in the formulas. Do that now. Place your cards into your pattern and then move on to the next slide. Compare your solution to the one that's shown on the screen. Did you add those 2 new cards where they're shown? If yours is different, I want you to take a moment now to think about how yours versus this one. And I want you to understand why the cards fit best into the existing pattern where they are shown now. When you're sure you get that, here are 2 new cards. Put them where they best fit into the pattern of the cards that are already in the table. When you've done that, move on to the next slide. Don't move on to the next slide until you've placed your new cards. If you just move through and copy my solution into your solution, you're not going to be able to finish the rest of the assignment. It's important that you take the time now to try to figure out what patterns are in these cards. It is a bit like playing solitaire. Now I want you to look at this solution where the new 2 cards have been added. Find the card that has atomic mass 24.3. Can you tell why I decided to put it there rather than someplace else? As we go down, we see that ionization energy has gone from 899 to 738. And we see that atomic mass has increased from 9 to 24.3. Both cards have the same formula for chloride, and both cards have the same formula for hydride. That's the XH pair. And both have the same formula for the oxide. That's XO. Now I want you to look at the top part of the table and see if you understand why the second card was added to that part. Are you beginning to get the picture? Your task is to take the rest of the cards in your deck and complete the arrangement by placing the cards into the table where they best fit into the pattern of the cards that we've already laid out. There are better answers than others, but there's really no wrong way to do it. You will also notice that one of your element cards says missing element. That is exactly what Mendeleev contributed to the development of the periodic table that previous scientists had failed to recognize. When we place cards out on the table like this, putting them in logical order based upon a pattern you will eventually find a place where you expect to have a card with a certain formula or a certain ionization energy or a certain atomic mass, and you won't find it in the deck. That is where your missing element will go. It will probably take you 15 minutes to finish this part. When you have finished arranging that, you will be putting the answer into your data sheet. So flip to the next slide now, where we have another assignment explanation for you that you can keep on the screen while you arrange your cards. Now that we've worked through this partway together, it's time for you to finish putting together the rest of your periodic table using the remaining cards that aren't in the pattern. Your final periodic table arrangement is to be written into the data sheet using permanent ink. Read the instructions carefully. It might take you up to 30 minutes altogether to complete this exercise. That includes the time you've already spent in this presentation. I want to point out to you that the very last post-lab question, you need to keep your periodic table together out on the desk, because in order to predict the properties of your missing element, you're going to need to use all of the data that's on the cards. When you're finished with that page, you're going to turn it in to Mr. Fain and Mrs. Schmidt.